Just a couple of things before we get on to the next section. I wanted to point out that we have now posted the slides for each of us on the OSCON website for this workshop. So I've just posted them in the comments, so you should find 3 slides. And I know that we're moving pretty fast through quite a lot of content here because it's hard to sort of teach Linux in just like 3 hours. But we have spent quite a bit of time putting together all the exercises that we're demoing up here. So on the GitHub webpage, like you'll find Jessie's file system, all her everything that she sort of went through live before is explained in detail in some exercises. So you can try those at home. And similarly for the kernel exercises that I'm about to go through, again, they're on the GitHub webpage, and feel free to even pull that up now as I go through them to give you a bit more context. So, awesome. Okay, so for this section, we're going to talk about the Linux kernel. Does anyone know what the kernel is, or can anyone sort of explain what the kernel is? Anyone want to guess? Yeah.
It's how the operating system talks to hardware.
Yeah, absolutely. That's really great. And Wikipedia defines the Linux kernel as, or even just the kernel, as a computer program that manages input-output requests from software and translates them into data processing instructions for the central processing unit and other electronic components of a computer. Or more simply, the kernel is just code. And it's a lot of code, 15 million lines of code, but just code nonetheless. And it's code that's been compiled into a program and loaded into your computer's memory. The kernel is really the brains of the operating system. It's responsible for things like process scheduling, where the kernel scheduler allocates CPU time to each program on your system wanting to run, so that if you were to look over a timescale of, say, a few seconds, you'd have the illusion that your computer is running several programs at the same time. And it also provides a really nice layer of abstraction between hardware and the application programs running on a computer. When you install a version of Linux, it will come pre-installed with a specific version of the kernel. But you can update this at any time. Linux kernel versions are hosted on a website called kernel.org, which I've got pasted here. And you can download any version of the kernel that you want as a tarball. And all a tarball is basically a compressed file or compressed directory. And it contains a bunch of C code and some scripts that enable you to build it. Linux source code is also called the kernel tree or source tree, so you can use those terms interchangeably. And you can see here that alongside this list of kernel versions, they're marked as either long-term, stable, or mainline. So for long-term, there are several long-term maintenance kernel releases provided for the purpose of backporting important bug fixes for older kernel trees. For stable, after each mainline kernel is released, it's considered to be stable. And any bug fixes for a stable kernel are backported from the mainline tree. And lastly, we have mainline, and this is the tree maintained by Linus Torvalds himself. It's the tree where all the new features are introduced and where all the exciting new development happens. And new mainline kernels are released every 2 to 3 months. So how does Linux get updated? Well, I mentioned at the beginning of this workshop that Linux gets updated every, couple of months, but it's kind of an interesting process. So there is exactly one person who can merge patches into the mainline kernel repository, and that's Linus Torvalds, the creator of Linux. But of the tens of thousands of patches that go into each Linux kernel version, only a very small percentage were directly chosen by Linus himself. The kernel code base is logically broken down into a set of subsystems. networking, memory management, video devices, etc. And most subsystems have a designated maintainer who is a developer that has overall responsibility for the code within that subsystem. These subsystem maintainers are the gatekeepers for this portion of the kernel that they manage, and they're the ones who will usually accept patches for inclusion into the mainline kernel. Subsystem maintainers each manage their own version of the kernel source tree, and they use the Git source control tool. And so like we've been using GitHub today, that's where all our workshop exercises are, but who here has used Git or is somewhat familiar with Git? Quite a lot of you. Does anyone know who invented Git? Yes. So it was Linus Torvalds. So not only did he invent Linux, he invented Git too. And, you know, he invented it because he wanted to be able to manage all of these code changes a bit more efficiently. So Git allows maintainers to track lists of patches, where a patch is a small text document containing a delta of changes between the code that the programmer wants to change and what already exists in the tree. So when the merge window opens, top-level maintainers will ask Linus to pull the patches they've selected for merging from their repositories. And if he agrees, the stream of patches will flow up into his repository, becoming part of the mainline kernel. And the amount of attention that Linus pays to specific patches received in a pull operation can vary. So sometimes he might look really closely, but as a general rule, he trusts the subsystem maintainers to not send bad patches upstream. So we talked before about kernel versions. So there's a couple of ways that you can find out what version of the kernel you're running. So one of them is to use the uname command, and you can type uname-a, which spits out a whole bunch of stuff. Or to get just the actual version that you're running, you can type uname-r. You can see here that we're running 3.19.0-18-generic. Another command that you can use is to cat a file in the proc directory called version. And again, it says that we're running version 3.19. So we're going to go ahead and learn how to configure and build our own kernel. One of the ways that makes Linux as an operating system really flexible is that you can take more control over how it runs. And one of the ways to do that is to keep it updated by configuring and building like the newest versions of the kernel as they become available. So there are a few reasons why you might want to do this. Firstly, so that your system can handle new and specialized hardware. So for example, I recently configured and built my own kernel because I wanted to be able to run Thunderbolt drivers, and that sort of driver only became available in like later versions of the Linux kernel. A second reason is like to speed up boot time. So what you can actually do is remove any unused, any parts of the kernel or device drivers that you won't use so that your system boots up more quickly. Also, it's fun to run the latest and greatest, and of course, to learn about Linux kernels. So there are 3 steps involved to configure and build your own kernel. Firstly is to get a copy of the kernel source tree. And you can get this from that kernel.org website, which we saw before. Secondly, you configure it, and lastly, you build it. So we're going to go ahead and do that now. So if the internet was working properly, we would basically just like choose which version we wanted to actually build. And I just sort of copy the link address here and use a program called curl to download that tarball. But the internet is not really working. Luckily, we have a backup on the system. So instead, what I'm going to do is change to this directory called user source, and you can do that as well. This directory contains the versions, contains all the kernels that are installed on your system. We saw by running the uname-r command that we're running 3.19. So what I'm going to do is copy, firstly, actually I'm going to do run this command called sudo-i. And what that's going to do is change my whole terminal to be running in super user mode, because when you're dealing with a kernel, you need to be running with those type of privileges. So that's I'm going to have to change back into user source again after running that. We have copied some files into a directory called home vagrant handy workshop files and Linux 4.0.5.tar.xz. So I have just copied that from the kernel.org website previously and loaded it into that vagrant image. So I'm going to run the cp for copy command and copy that tarball into user source. So if I list the contents of that directory now, I can see that that tarball is now there. So we're going to unpack that now, and we use a command tar-xvf to do that. Oh, what's the command? Oh, I have to specify the file. And yeah, please follow along with me. Awesome, okay, so that's unpacked. And if I list the contents of this directory again, we can see that the Linux 4.0.5 directory has been created. So I'm just going to change into that, cd. And if I list the contents of that directory, we can see it contains folders like Arch for architecture, crypto, drivers, firmware. And I'm just going to take a peek inside drivers. And I can see like a whole bunch of stuff here. And if I change into, say, the Bluetooth directory and list the contents of that, you can see there's just a whole bunch of C code. So again, all we've done is downloaded a whole bunch of C code that makes up the kernel source tree. So I'm going to change back up to just the root directory Linux 4.0.5 again. And what we're going to do now is configure, learn how to configure the kernel. So there is one thing that we need to install to do this, and I'm hoping the internet will work. Let's see how we go. So I've done a sudo apt-get install libcursors5-dev. And that's just like a little program which allows us to run this little GUI thing, which you'll see in a second. So go ahead and install libcursors5-dev. Again, if I'm moving a bit too quickly, all these instructions are on the GitHub website. If you click on workshop and then kernel, there's the README there should have all these instructions. And then the next command I'm going to run is make menu config. Oh, interesting. Has anyone else got this screen up? Or, yep. Still installing? Okay, cool. Might just hold up a second. So I'll bring up the instructions. Cool. So for those that just got it installed, run make menu config. Yeah, that's right. Cool, and then you'll get this really 90s looking screen. That's what the libcursors5 thing allowed us to do, was to run this. So this is like a GUI that allows you to configure your kernel. And there's a bunch of different ways that you configure your kernel. You can just sort of do it by hand by editing like a text file, but this menu makes it a little bit more easy. So there are over like 1,500 different kernel configurations, so you wouldn't really want to go and configure everything by hand all the time. Generally what people do is, when they do go to configure a kernel, is copy over the configuration file for their currently running kernel, and then just edit the things that they want to. So maybe, for example, I mentioned before that Thunderbolt sort of only came in later versions of the kernel. So I might have copied my old config file over and just edited the new configurations for new features in the kernel. So looking around, there's a whole bunch of different stuff that you can configure. The main thing that I want to do for this configuration is to enable Thunderbolt support. So if I go back, so from the main menu, I've just popped down to device drivers, pressed enter on that. And I know it's all the way down the bottom of this really long menu, so I'm just gonna scroll all the way down. Okay, and it's second from the bottom here, and Thunderbolt support for Apple devices. So there are 3 ways, I guess, that you can configure most options. You can either not install it. You can install it as an M, and M here stands for module or kernel module. And what that means is that this device driver will only be added to the running kernel when you plug in a Thunderbolt device. And when the device is unplugged, that bit of code will be unloaded from the running kernel. If I press spacebar again when the asterisk comes up, that means that this device driver will be baked into the kernel. So it'll always be there. The code will always be loaded regardless of whether a Thunderbolt device is connected to my laptop or not. So the advantage of installing kernel modules is that you only use up as much memory as you absolutely have to, and it also speeds up boot time. So because your kernel doesn't have to load all of these modules that you may not even need, it speeds it up if you just decide to install it as a kernel module. So that's the change that I wanted to make. So I'm going to hit save. It asks for a file name. .config is the file name that we want to keep. Press and exit, and then I'm going to exit. Cool. So if I list the contents of that directory, I'll now see that a .config file was created. And if we cat the contents of that directory, of that file, sorry, we can see that all it is like a bunch of, different options with sort of like Y or N next to them. And so I could actually go in here by hand and edit some of these configurations as well, but that's the other option to using the GUI. So one other cool trick that I wanted to show you was to create our own kernel release version. So we saw before that the currently running kernel version is 3.19-0-18-generic, which is pretty boring. We can jazz that up. To do that, we can open the make file, And you see this extra version field here. We can add something like rainbow unicorns Linux fun, for example, because that sounds really cool. And before I save and quit that file, I want to show you, point out this thing, name equals herder, I'm a sheep. Does anyone know what that is? Has anyone heard of that? That's actually the current name for like Linux kernel version 4. Like that's like their name of it. I don't know how they came up with that, but I think it's kind of funny. So, all right, so I'm going to save that file with dash rainbow unicorns Linux fun in the extra version field. You guys should like choose something fun for yours. And what was the command again? Okay, and then to work out what our kernel, final kernel version string will be, we can run this command make kernel release. And it comes up as 4.0.5 Rainbow Unicorns Linux Fun. So when we build this version of the kernel that we've just configured and we run a uname-r, that would be the string that comes up. So how do we go about, so now we've configured the kernel. The final step is to build it. So to do that, you need to run, again, there's multiple ways that you can build a kernel. One of the ways is to run a few different make commands. And make is just a handy tool that builds, that helps you build C code. So the first one is make install. I think it's make install. No, it's make all. Make all, and that's going to build the kernel. The second command that you run is make modules install. And that would go ahead and install all of those features that were configured with an M in that GUI menu, such as our Thunderbolt driver. And I'm just chaining these commands together with a double ampersand, which is just another thing that you can do to chain things together. And the final one is make install, and that actually goes ahead and installs the kernel. Now, this actually takes a really long time, so we're not going to do it. In fact, like about an hour and a half it takes. So we can't do that in this tutorial because it would take up the rest of the time and be super boring. So what we're going to do instead is install a already pre-built kernel 4.0.5. Okay, so what we need to do is change back into that home vagrant handy workshop files directory. And in there's a directory called mainline kernel 4.0.5 debs. So I'm going to change into that. And if I list the contents of that file, there's 3 .deb files there. And I have gotten these off the Ubuntu website. So Ubuntu goes ahead and builds, like packages up each version of the kernel that comes out. And this is going to be much quicker because it's already been compiled. So it's the compiling that really takes a long time. So what we're going to do is install these already compiled versions. And to do that, I'm going to run a command which is dpkg -i star.deb, and all the star.deb does is just get everything in this directory, current directory, that has .deb at the end of the file name, and press enter. And this is going to go ahead and install this 4.05 version of the kernel. Yeah, absolutely. So again, I might just pull this up for a second, because all the instructions are also here. So install a pre-built kernel. So change into this home vagrant handy workshop files mainline kernel star.debs directory, and then sudo dpkg-i star.deb. Mine's still installing. Does anyone need help? Yep. 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 No, we wouldn't have ended up with deb files. That's like a slightly, you need to run a different command to create the deb files. The deb files are sort of unique to like Debian distributions and the package manager with Debian like distributions. So the make commands can be run on any type of Linux distribution and it'll build it.
So if you're not winding up with a Debian file at the end of that install, because you have to run other commands to make your package, at the end of the make install, what do you have? Do you have a directory? Do you have, and do you have to reboot to get it to load?
Yeah, what do you have? I can't remember now.
The
compiled source tree, yeah. Yep.
So is it a directory of compiled files?
Yeah, on your host system, it's the kernel modules are all loaded into like that versions directory. Yeah.
So compiled C code. We're actually going to go over that next. Yeah. So mine has finished installing. Can I just see a show of hands? How did people go with like installing that version? A few people? Cool. Awesome. Okay, great. So we just installed a version of the Linux kernel, which is cool. And now I'm going to So now we're going to talk about how we boot into this version of the kernel. So I'm going to just talk a little bit now about how the boot process in Linux actually works. And then we're going to go ahead and boot into this new version of the kernel that we installed. So I said before that multiple versions of the kernel can be installed on your Linux distribution at any one time. But only one version of the kernel is chosen to run, and this is done at boot time. So how does the kernel get loaded? At a high level, when you press the power button, the motherboard is powered up and it'll initialize its own firmware and then request the CPU to start running. With a multi-core processor, a single CPU is dynamically chosen to be the bootstrap processor that will be in charge of running all of the BIOS and initialization kernel code, with the remaining processors halted until they are initialized later by the kernel. The CPU will execute some BIOS code, which will in turn initialize some hardware, and if things don't look quite right, it might error out here. But if everything is going smoothly, then it will read the first 512 byte sector of the hard drive, and this is called the master boot record, or MBR. The master boot record contains the first stage of something called a bootloader. Some popular choices for x86 architecture are grub or lilo, and our version of Ubuntu runs grub. The bootloader's first job is to decompress a file called vmliners, which is a compressed kernel image, and it then loads that into a protected bit of memory. The kernel then sets up system functions such as essential hardware and memory paging before calling a function called start kernel. When start kernel is run, it will execute a wide range of initialization functions. It sets up interrupt handling, further configures memory management, device and driver initialization, etc., before kicking off init or systemd process. The kernel startup process also mounts the initRD file, which stands for initial RAM disk. And this loads a temporary root file system and allows all the necessary kernel modules to be loaded directly from memory. So I know that was quite a lot of new words and terms there. So just to make that a bit more concrete, if you change into the /boot directory, and take a look at the files there, we can see that there is a VM liners file for both 3.19 and 4.05 versions. And so that's the compressed kernel code. There's also this initRD, or initial RAM disk file, as well as a config file for 4.05, and again, just catting the contents of that config file is going to be very similar to what we saw before. So during that installation process of the kernel, these files were copied into the boot directory. You'll also see a directory called grub, and grub is the bootloader that Ubuntu uses. So we've installed a version of that later version of the kernel, but we're still running 3.19. So how do we load this new version? So grub automatically boots into the latest kernel version. So all we need to do is reboot. And I'm actually going to hold down the Shift key while I do this, and if everyone wants to try doing that too. And you'll notice that we've now popped into this menu. This is the grub menu. And if I go down to advanced options for Ubuntu, I'll see that both versions of the kernels that we have installed are available there. So there's 3.19 and 4.05. If I hadn't have gone into this menu and not pressed Shift and just let the system boot up, would have automatically booted into 4.05. But you can always choose to change which version of the kernel you want by jumping into this menu. So I'm going to select 4.05. Let that boot up. Cool. If I open up a terminal again and do uname-r, we're now in 4.05. So we looked at the contents of /boot before, and we saw that there's now versions of files for 4.05. And also if you look in lib modules, you'll see, if you list the contents of that, you'll see that 4.05 kernel version is there. And those modules, again, are like those device drivers or kernel modules that we've configured. Cool. So I wanted to talk a little bit now about the proc file system. Is anyone familiar with proc, or could anyone sort of tell me a little bit what it's about? Yeah.
So during boot, the proc file system is created, and it keeps track of all the hardware that the kernel has found.
Yeah, it's like... Yeah, exactly. So it's what we call a pseudo file system. So it's not a normal directory containing files that take up space on your hard drive. Instead, what it does is it acts as like a window into your currently running kernel, and it dynamically generates output about the running kernel. So it's really useful to provide that type of information about what processes are running. And most of the files in proc are read-only, but some of them you can actually write to, which means that you can dynamically change what's happening in the kernel at runtime, which is pretty cool. So if we change into /proc, and I'm going to do an ls-la. It's kind of hard to see because my text is zoomed in. Okay, so what I wanted to show you here by doing this ls was you can see how everything is 0, as in like the file size is 0 for all of these files in this directory. And there's also a whole bunch of these numbered directories. Before, Tammy showed you, talked about processes. And so running the ps command lists out the currently running processes on the system. And they all assigned a unique PID or process ID. So I can see on my system, PID 1567 belongs to the bash program. And so if I change into 1567, /proc/1567, this contains a whole bunch of files related to that process that is currently running on the system. So there's a directory for every process that's running inside of the proc file system. And proc also tells you some other things. So to read information from proc, you just can use the cat command. So if I use cat on CPU info, it's going to tell me a whole bunch of stuff about this system. You know, that it's got an Intel Core CPU, some other stuff that I don't really know about. CPU cores 1, because this is a virtual machine. Another one that we did earlier was to cat the version, which is again going to tell us that it's 4.05. So I mentioned that most of these files are just read-only and they just tell you information, but some of them that you can write to. So let's write to one of these files now. So I'm going to first run this command called hostname, and it tells us that our hostname is vagrant-virtualbox. So that hostname command actually just reads from a file in proc sys kernel hostname. So if I cat that, it's going to say the same thing. So if we edit the contents of that file, by using a command called echo, and echo just is going to copy this, like this string, Linux or death, into sys kernel hostname. Oh, I have to be in super user mode. If you're at the end of the line and you want to get to the front of the line, you can press Control A as well. That's kind of handy. Still permission denied. Oh, maybe I just need to change. Cool. Okay. So make sure you're in super user mode to do that. So if I now run the hostname command, it says Linux or death. And if I cat the contents of that file, it's going to say the same thing, which is pretty cool. So we just updated the kernel as it's running without having to, like, you know, shut it down or configure it or do anything like that by updating the contents of that file.
Is that persistent?
Yeah. Yeah.
And I noticed that
Sorry. Oh, with the echo command?
Yes. With the echo command, use the double arrows to append the file.
To append it like to the end. Ah, okay.
But it wiped out the original contents.
Yeah.
So that's because it's not a real file.
I don't know. That's a good question.
That's because it's just in memory. It's not a real file.
Maybe.
Yeah, but you can make it permanent. Doesn't that make it permanent by changing?
Yeah. So what is that?
So that's
So what's, yeah. I don't know what the difference is between the 1 arrow and the 2 arrows because,
It's redirection. One's different to two. One appends and one override.
okay,
I think that in terms of that, it was truncating it.
right. Cool.
So I guess what I'm saying is that anything that you write, if you find a file in proc, it's not really a file.
Yeah,
If you write to it, you'll be wiping out the original contents.
yeah,
That's something you should be aware of.
yeah. Yes.
Existing, so Etsy hosting, which I know Debbie, in the Ubuntu, maybe in all the distributions, has the host name that is in there. That's still the old host name.
Okay.
Is it reading from that when it did its hosting, or?
I think it checks multiple paths, but don't quote me on that.
There's a lot of different ways to change the host name.
Yeah.
You can even change it through.
So,
There's multiple ways to change the host name. It's a little bit inconsistent.
So it's more like just read.
Yeah.
You can-
like NM2TUI, you can change the host name.
Oh yeah, it's true.
You can even use the hostname command itself to change the hostname,
Yeah,
it looks
true.
like. Lots of different ways to do everything in Linux.
It's about choice.
Back to his question, where does it read from?
There's I think there's like a list that it goes.
A hierarchy?
Yeah.
Ah.
But I'm
So
not
where
sure,
is
and
it?
I think it differs per distro actually, even too, because on I think RHEL there's like sysconfig hosting too. Not sure. Yeah. Wow. I can't believe I know sysconfig. I'm a little sad for myself right now.
Okay. Good questions. I like it.